Hi everyone, this is again Dr. Vishal Sharma, principal at Metanoia Inc. and moderator of the Carry Ethernet group. And I'm really excited today to bring you a very special edition of CE Live, which is really designed to be a discussion around Bill Norton's paper on Direct Connect. So Bill, I've already sort of given a lot of introductions in my notes and preamble, but there's nothing like having you kind of introduce yourself. So please take a minute to tell people what are the things interesting things you're doing right now, and then we'll dive into the paper and talk more about it.
Absolutely. Well, hi. I can't see who all is out there, but thank you for taking the time to tune in. My name is Bill Norton, and I've been working on the internet since about 1987, if you can believe that. Here today, I work for a company called IIX, a specific subsidiary of IIX called Console, whose whole job in life is to provide interconnection between enterprise networks and cloud companies through a point-and-click interface, a portal that we call Console. And I've been working on this for the last 3 years. Prior to that, I worked as an independent consultant. That's how I got to go down to South Africa, to Masani, and work with some folks down there in the cable and telephony industries. And I put together a peering workshop that is loosely based on my book. It looks backwards, doesn't it? Actually, on my screen, it looks like it's right, but on the presenter screen, it's exactly backwards.
God, I love the building shown, eh?
Yeah, this the building in the middle here is an actual Equinix data center.
I thought it might be a data center.
Yeah.
Beautiful.
So prior to the Dr. Peering stuff, I served as co-founder of Equinix, a very large global data center. I think down where you are in South Africa, the closest thing to Equinix is a company called Terraco, where they do essentially the same type of business model as Equinix, which shouldn't be surprising. The folks who launched Terraco came out of Equinix in Europe, as I'm told. So I spent 10 years at Equinix researching how interconnection works. And what you see in that book, the Internet Peering Playbook, is an assimilation of all the things I learned in the couple of decades working in the peering industry. Prior to Equinix, I was involved in the North American Network Operators Group. I put together the business plan for it, and I was the first chairman of NANOG for the first 3 years of NANOG's existence. So anyway, that's my background. I'm still interested in interconnection, but today we're going to be focusing on a slightly different variation than what I wrote about in the Internet Peering Playbook. So with that, shall I just dive into it, Vishal?
Yeah, while you're switching screens, let me just, for the benefit of the viewers and, of course, anybody who will join us, do a few housekeeping points. So, guys, if you're joining us through the Google Hangout, you should be able to see the group chat. That's an opportunity for you to ask questions. The other way you can ask questions is right in the abstract of this presentation. I've given a link to Bill's post on the Carry Ethernet group. So if you are a member of the Carry Ethernet group, you should actually post the question right under that post. Periodically, I'm going to refresh my page and see if there are any questions from the attendees. So attendees can, join the group chat if you are not a member of the Carry Ethernet group, but if you are, then the preferred mode is to go post your question right below Bill's posting, and the link to that post is right in the abstract. So you click on it, you can go there. And then, as I said earlier, this is all live. So if some glitch happens and we disappear, please don't go away. We'll come right back on, and we should be able to get this thing started. Or somebody drops off, don't worry about it. We just keep going. And I think it'll last about an hour, and we want to make it interactive. There might still be other people who may join us, because several others had indicated interest, so you might find some more folks joining the video call. But other than that, I think Bill, it's your call now.
Okay. Well, I guess one of the first things I'd like to do is get a sense, if we can, maybe using this chat window, where folks are from. I know that Dumasani is there from Joburg in South Africa. If you guys are on the chat list, go ahead and give me a sense of where you're coming in from. I'm doing this mostly because I'm actually pretty impressed with Damasani's video. I mean, it's pretty amazing that this is across the opposite side of the world, and the video quality is actually pretty good. It's
Can I confess then, Bill? I'm sitting on a backbone of an internet service provider, Internet Solutions. That's why bandwidth is not a challenge.
But even the latency is not that bad. I tried doing some conference calls to South Africa over the public telephone network, and it just did not work at all. It was god-awful. But here, we can do video, and it looks pretty good. So
yeah, so we have a few viewers. We actually do have 3 viewers. So you know, if you are in Google Hangout and you can join the chat, then please, as Bill said, you know, tell us where you're from, or type it in. And if you can't get to that chat, then just type in that post in LinkedIn, and you know, we'll refresh that and see that. But yeah, so hopefully as we get that, Bill, we can still continue, and we'll let the folks you know, type in their locations. Okay.
Absolutely. Okay, so let's go ahead and get started. The purpose of today's talk is to explore a new interconnection regime, relatively new interconnection regime called the Direct Connect service model. And the purpose of the paper initially was that I wanted to understand how this Direct Connect system works. How is Direct Connect different from peering? I wanted to understand when does it make sense to go and use the Direct Connect way of connecting to Amazon, Microsoft Azure, Cloud, Google Cloud infrastructure. When is that the right mechanism, and when is it good enough to go over the public internet to access various cloud services? So I started working on this about 6-7 months ago, spending a lot of time talking with cloud companies, with people from enterprises, with people that have actually set up and connected into these various different services to share their insights. And I also spent a lot of time looking at the documentation that was available on the Amazon website. And what I was able to do is construct an initial draft of a white paper to see if I got it right, and then I spent the next 6 months walking people through that white paper, having them give me suggestions, tell me where the flow doesn't make sense, or where I got the facts wrong, or what I should do. And through a stepwise refinement process, what I'll share with you is the white paper in its current form after about 60 walkthroughs. So this is data collected from about 6. Let me start out by saying that as a matter of introduction, that what we've seen happening since I've been working on the internet was that Vint Cerf's and Bob Kahn's initial experiment creating an internodal packet switching mechanism has been a great experiment that's actually blossomed into this massive global ecosystem, and it was based really fundamentally on this idea of openness. That is, the packets for the internet are well defined and documented in an easily accessible form. So you can actually look and see the initial documents that described what the packets would look like. And if you can create a packet that conforms to that specification, you can inject that into the internet, and the internet will do its best job to get it to the destination as specified in the packet. So that's the good. The bad is that this also means that miscreants can create packets that are well formed but have malicious intent. For example, a common approach would be to spoof the source address of a packet, so when it gets injected into the internet, it will travel along the path to the destination, who will respond to that spoofed address. And when you send a small request for information that generates a large response as a result, that large response goes to that targeted destination and can overwhelm that target if it happens enough times, if there's enough traffic volume. So miscreants can effectively put together a denial of service attack using well-formed packets. So that's the bad. The ugly is that miscreants have now gotten to the point where they take over, compromise personal computers around the world. They have a command and control system called a botnet that can launch these denial of service attacks with multiple gigabits per second into tens of gigabits per second. Now in 2015, we're seeing denial of service attacks in the 300 to 400 gigabit per second range, lasting for many days at a time. So that's pretty ugly. The problem isn't so much that the target is getting overwhelmed, although that is a pretty bad problem. The problem is that the infrastructure used to deliver all of this attack traffic is shared, and anyone that is using the same paths that the attack traffic is traversing will experience potential problems in the form of latency, as all that attack traffic has to be queued up, so you'll see additional queuing delays. You'll see additional packet loss, as your packets are just as likely to be dropped as the denial of service attack traffic. So that introduces some problems with performance and security. For these reasons, back in 2011, Amazon introduced the Direct Connect solution, allowing customers who deemed it critically important that they have consistent and reliable access to their Amazon Web Services instances, that they can connect through the Direct Connect service and bypass the commodity internet.
And Bill, a quick question there. So Amazon basically opened up and they gave essentially enterprises an interface that they could plug into, but the job of getting that direct connection was still the responsibility of the enterprise, right?
That's correct. The model was that they were willing to open up their Amazon Web Services network to a specific service model, so that if you can bring a circuit and plug it into that port, you will have direct access. But by and large, you are the one who have to order the circuit, provision the circuit, test the circuit, set up your router, configure your router to peer with the Amazon Direct Connect instance. And it's a bit of a cumbersome task. It's a bit labor intensive, but for those who really require that level of security and reliability and better performance, that's fine. That's a reasonable cost to them.
I see. And then do we have, I mean, and this is just, we may or may not know this, but do we know what kind of a take rate this Direct Connect service had over these last 5 years? I mean, it must have started out small, but then did it just kind of shoot up? You know, any thoughts or ideas about, you know, how open enterprises were to actually doing this?
Yeah, I don't have specific numbers. I haven't seen specific numbers posted, but my sense from participating at the Amazon Web Services reInvent event in Las Vegas a couple weeks ago, my sense is that we're talking about a few thousand entities that have gone down this path. It's not 100,000, it's not less than 1,000, it's in the thousands type of range.
That's still pretty good. I mean, that is pretty good. I mean, I'd imagine these are large enterprises for the most part.
Yeah, really it comes down to do you have a need to directly connect? Have you experienced any connectivity problems? We'll get into that in a second.
Sure.
So the idea behind this white paper was, let me go through the process of learning and understanding how all this stuff works by talking to as many people as I can, and really I want to identify from the field, not from the web pages what Amazon says is the case, but really identify by talking to the people on the ground that are actually using this stuff. What are the pros and the cons with using Direct Connect or the internet for accessing these critical cloud services? I also wanted to find out what is the cost of connecting over the internet to these cloud services versus connecting by using a Direct Connect service model. And then finally, based upon all the data I've collected from the field, what are my recommendations, and where is the sweet spot for direct connect? When can I, as a Dr. Peering, if you will, prescribe to a particular customer that direct connect is the right approach? I wanted to understand all of that. So that's the purpose of this white paper. So let's start out by talking about the Internet Connect service model. And by the Internet Connect service model, I should point out up front, what I'm trying to do is not necessarily limit this to the Amazon Direct Connect offering. I want to make both sides generic in this white paper. I don't call it the Direct Connect service. I call it the Direct Connect service model, meaning that other entities like Google Cloud Infrastructure and Microsoft Azure and others have something similar. So even though Direct Connect is kind of tied to Amazon, I wanted to make it a more generic phrase, the Direct Connect service model. And therefore, I'm calling accessing the cloud service over the Internet the Internet Connect service model. Does that make sense?
Yeah, it does. But is this terminology that is something that you kind of started to instantiate, or is it something that people in the industry tend to use?
No, this is something that I've come up with because I want it to be generic. The individual vendors, Amazon calls it Amazon Direct Connect. Microsoft Azure has a different name. It's something like Speed Route, or there's a different name for it. And Google, they all have a different name for essentially something very similar.
Got it.
Yeah. Okay, so generically, the Internet Connect service model is defined as a system used to collect cloud services over the public internet. So in the picture you see on the left, there's an office or a data center that already has access to the global internet, and it simply uses that pre-existing connection to the global internet to access, among other things, various cloud services that it wants to use. And of course, there's some really great things about accessing cloud services over the internet. Specifically, the pros include things like ubiquity. Everybody already has an internet connection. So from a networking perspective, you don't need anything else. The other implication of that is if you decide after you connect to Amazon Web Services and you're liking what you're seeing, and you want to also connect to Microsoft Azure or these other companies, maybe Box or Dropbox or Salesforce, you don't need to do anything else from a networking perspective to add those additional ones. You simply use your pre-existing internet connection, and you can add instantly whatever cloud services you want. And then finally, the other benefit of using the internet for accessing cloud services is that it's priced on an a la carte service model. So you pay for what you use. If you are sending and receiving a lot of traffic to and from the internet, then you pay more than if you are not sending so much. This, of course, is assuming that you're buying internet transit, not in the residential market. In most parts of the world, in the residential market, it's a flat all-you-can-eat sort of system. But for most enterprises and large, medium-sized content companies, they're buying on the 95th percentile typically. So that model of purchasing internet transit in that way is very similar to the way that companies will purchase and use cloud services.
So Bill, it might be useful to take 1 minute to you said something about the 95th percentile. Not everybody may be familiar with that, so maybe you can just take 30 seconds to just tell what that 95th percentile terminology means.
Sure. The 95th percentile, the network service provider has a meter on the internet service, and they measure on a 5-minute interval how much traffic is sent and received across that interface. They measure in terms of bits per second. So they take a snapshot of the number of in octets and the number of out octets on the interface. And they do that sampling every 5 minutes. They take all those samples at the end of the month and stack them from lowest to highest in order to find out what is the number of bits in and bits out at the 95th percentile measurement. The implication there is that you can burst and peak above the 95th percentile, and it won't cost you any more money. That was the intention behind that billing model in the first place. Because the idea was that internet traffic tends to be very spiky, and those spikes may increase your the cost of your internet transit service. If you have super high spikes, that can really offset the average. So the 95th percentile measurement was put in place as a way to allow 5% of that traffic to be spiky and out in the stratosphere in terms of volume, but not adversely affect the customer's overall internet transit bill.
Wonderful. Got it.
Yeah. Sorry, Bill,
Okay.
just to jump in.
Yeah.
I know this might not be part of what we're discussing today, the whole 95 percentile discussion. Are you finding this still a relevant model, given that our customers are looking for more of a bandwidth on demand model in the future? We've just canned it as a business here, for an example, because of preparing for the future. And I would like to find out if you guys are still making use of it in your end of the world.
Yeah, 95th percentile has kind of been around since the commercialization of the internet. We went through a number of iterations. At first, people were charging based upon capacity of the pipe. The problem is when you go from a 1 meg pipe up to a 45 meg pipe, that's a pretty big jump, and customers weren't really willing to pay that big increment when they weren't going to be using that much more traffic. They were just saturating that 1 meg pipe. So since we've, in this part of the world, what you're finding more and more is that we're not talking about megs anymore. We're talking about gigs and tens of gigs. And at that level, it still is pretty much priced at the 95th percentile. You will find some providers that are offering an all-you-can-eat model where they'll sell you a 1 gig or a 10 gig pipe, and it's a flat rate, so use whatever you can. That's not generally the way that the large providers are offering that in this part of the world.
All right, cool.
So one quick question, Dumisani. So if you guys are getting rid of the 95th percentile, have you decided what you're going to replace that with? Like, what is the alternative metric, or that's still a work in progress?
Well, currently we're doing exactly what Bill just mentioned, and all you can eat. We're finding that our customers really just want more bandwidth. That's what's driving them. And if you're saying, here's a pipe, consume as much as you can, they will do that.
I see, I see. Okay, cool. All right, let's move on, Bill.
Okay, so those are the pros of using the internet for accessing cloud services. But there are a number of substantial and worsening cons as we speak. The first is the security vulnerabilities on the public internet. And by this I mean, if you take a look under the covers of the commodity internet, what you find is that on average there are 4.3 networks in between any source and destination across the internet. 4.3 networks, each of which is composed of routers with publicly addressable IP addresses. Each of those routers, within each of those 4.3 networks in between you and where you want to get to, each of those routers has links interconnecting them to other routers. The routers today can be compromised if they can be addressed, and if they're attacked. The links can be captured, the traffic can be captured and mirrored and redirected. These are things that happen today in the internet. And the point is that the security folks that I spoke with would take a look at this picture and say, what we have here with the public internet is a, quote, large attack surface. All those publicly addressable routers could be compromised. There, in fact, is a black market where routers are leased from those who have taken them over. And you can lease routers. Usually on the black market, they're leased in exchange for stolen credit card numbers and things like that. So there's a whole underground economy based upon these compromised routers. And once you compromise the routers, the links are subject to be vulnerable. So this is a bit of a problem in the industry. If we take a look at the keynote that hey, some animation did come through there.
Cool.
So you can see that your traffic is traversing an awful lot of routers and links. And the point is, like I said, the security guys call this a large attack surface. At the last North American Network Operators Group, Jack Waters gave the keynote. And I thought he said it really quite well. He said the most awesome thing about the Internet and the most horrible thing is that everything is addressable. And when you really get down to some of the big security flaws there are in the system, it is because of in-band signaling and the fact that everything is addressable. So that's, in essence, the large attack surface was seen as a big problem with the commodity Internet. The second problem with accessing cloud services over the Internet is reliability. And by this I mean that across the Internet, your traffic is traversing the same paths that the attack traffic is traversing. So if there is an attack on the public Internet, maybe attacking someone that's unrelated to you, your traffic could just as easily be dropped as the attack traffic could be dropped. So that's a problem accessing over the Internet. You might have 99.99% reliability sometimes, but that's not across the entire system. From end to end, the chances of there being a reliability issue is substantially greater on a month-by-month basis. As evidence of this, I refer to the Priceline presentation at the Croatia European Peering Forum. Gregor presented there the a graph that showed their A/B test, where some of their traffic traversed their Internet Transit Service, and other traffic went over a peering link. And what you saw over time was that the Internet Transit link would periodically show great spikes of latency and the occasional packet loss. One was conjecturing that this was probably some routing adjustments that were taking place. And it takes a little while before routing stabilizes. Maybe there's a cut somewhere along the path, some kind of disruption. At the same time that we saw that disruption across the Internet Transit Service, we saw a wonderfully flat line peering interconnect. The traffic across the peering link suffered no problems. So in terms of the cons of accessing cloud services over the commodity Internet, I point to reliability being one of the issues, because you are subject to what happens across the shared links and routers across the path.
But Bill, one quick sort of question just came to my mind. So when we talk about direct connect, I mean, strictly speaking, it could actually be a tunnel that is built over the Internet, right? I mean, you could do that. Of course, you could still imbue the tunnel with properties where it's got, you know, a fixed bandwidth and so on. So while it's still being routed over the Internet, you are somehow shielded from some of the vulnerabilities if you were just using the plain vanilla Internet. Is that a possibility, or when we say direct connect, it really is a completely separate private connection?
Yeah, when I say direct connect, and I'll get to that definition in a minute, what I mean is a complete Internet bypass. Okay. We call the VPNs making the best of a bad situation, because ultimately the VPN has to traverse the same public Internet, and therefore is subject to the same reliability issues. Traffic that goes across the commodity Internet could be traversing the same path as a massive DDoS attack against the Oprah Winfrey Show, for example. Sure. And if your traffic was unfortunate enough to be on that same link, then that VPN is going to be sluggish and not be able to deliver the traffic until the underlying infrastructure is more solid. So it's making the best of a bad situation in the sense that the traffic is at least encrypted. However, we would point out that encrypted traffic can be mirrored, take some days, some weeks, maybe even some months, but ultimately that encryption may not be getting you the security and privacy that you think it's getting you.
Sure, sure, got it.
Yep. In terms of performance, the issue with the Internet on the performance side is that the shortest path between 2 points is a straight line, and what you see in the Internet is far.
Just so you know, the screen share is no longer active. I'm not able to see the screen anymore.
Hmm.
So you might have to redo the screen share bit.
Okay. There we go.
I can see the presentation.
Okay, so in terms of performance, the shortest path between 2 points is a straight line, and what you see with the Internet Connect service model is far from a straight line. In fact, you saw all the different hops and routers that are in between the two endpoints. So the performance is not only highly variable, but it's also not the shortest path. Then finally, during the walkthroughs of this paper with other folks, they said, you know, Bill, the thing you forgot to mention is probably the most important to us as an enterprise and as a software as a service company, and that is control and visibility over the end user experience. And what they point to is the fact that when there is a problem in an intermediary set of networks, maybe 2 networks away, has an interconnect problem with a network that's 3 network hops away, you don't necessarily have access to the network operations center of those intermediary networks. In fact, you probably don't. The network operations center is only taking phone calls from customers or from peers. And since you as a SaaS company or enterprise are neither, they won't take your phone call. You can't contact them and say, hey, I'm seeing some packet loss between you and one of your peers. Can you take a look for me? You don't have that kind of visibility, and you don't have the kind of control that can say, I want my traffic to bypass that congestion point. So that's really a fundamental problem that Direct Connect will solve, as we'll see in the next couple slides.
Actually, that's a very important problem that people probably don't realize, right? I mean, the fact that you don't really have any control over performance problems that show up in route. And you know, you can do end-to-end testing, but there's no way to really identify a problem once it happens if it's in a network that you don't really even talk to.
That's right. And to you know, further amplifying that, one of the things that we noticed even back in the early NSFNet days 2 decades ago was that the most difficult type of performance problem to address is an intermittent performance problem. And you don't know when that problem is going to come up or how long it's going to last. Chances are good if you file a report with your upstream ISP and say, hey, I'm seeing a performance problem, by the time they get somebody who's trained to look into that stuff, the performance problem may be gone already.
Sure, exactly.
Anyway, so those are the pros and the cons of accessing cloud services over the internet. Let's take a look at the cost. Now, the way I did this is I created a model between an enterprise and a cloud service. I'm assuming in this case that the cloud service I want to connect to for the purposes of modeling this is Amazon. And the reason I chose Amazon is that Amazon, according to Gartner, Amazon is 10 times larger than the next 14 competitors combined. Amazon's 10 times larger than the next 14 competitors combined. That's right. So for that reason, I figured if I modeled connection to Amazon, that I would do the most good for the community and have some reasonable numbers to work with. So there are 2 cost components to accessing Amazon over the internet. The first is the internet transit fee. That's the cost of accessing Amazon over the internet. And the second is the data transfer fee, which is something that Amazon charges the user. Amazon charges the user based upon the volume of traffic that is delivered from Amazon on your behalf. I said from Amazon because it's only in that one direction. Inbound traffic into Amazon is free, but outbound you pay for. Okay? So the way that I modeled this, where I said, okay, well, let's take a look at the Internet Transit Service. Here in the U.S., it wouldn't be unreasonable to make an assumption that an Internet Transit Service provider might charge $2 per megabit per second for Internet access. Now, in some cases, folks would say it's less than that. In some cases, folks would say, well, you know, enterprises tend to pay more than that. I attended an Oklahoma IT symposium where I asked this question after presenting this slide, and the group said, well, you know, we might be paying $350 per megabit per second or $4 per meg, but $2 per meg is not unheard of. So I'm assuming in this case we're going to have a model where an enterprise has 50 megabits per second of traffic to exchange with the cloud service. And at $2 a meg, if you do the math, $2 a meg, 50 megabit per second, that turns into $100 per month. So we see the cost of accessing Amazon Web Services over the internet in the order of 50 megabit per second is not a terribly expensive proposition. It's $100 per month. We're also assuming here, though, this is a simplifying assumption, that the 50 megabits per second of traffic is non-stop, sustained, bidirectional 50 megabit per second. And you'll see later on, as we apply the same numbers and the same model to the direct connect model, that we're going to need to be able to make that simplifying assumption so we can do the math. So we're assuming 50 megabit per second non-stop, sustained traffic is going to and from Amazon Cloud Services and the enterprise. The second cost component of accessing the cloud service over the internet is what Amazon calls the data transfer fee. This is a volumetric measure of how much traffic on a monthly basis is sent out of Amazon. And here is where our bidirectional simplifying assumption comes in. We're going to take our 50 megabit per second and figure out how many gigabytes that will generate when it's a non-stop sustained 50 megabit per second. Now, the other thing I need to point out is that the Amazon pricing model is that they will charge you 8.5 cents per gigabyte downloaded for the first 10 terabytes, and they will charge 8 cents per gigabyte downloaded for the next 40 terabytes. So if we take our 50 megabit per second and divide that by 8, that will give us the number of megabytes per second. If we divide that by 1,000, we get the number of gigabytes per second. And we're going to multiply that times the number of seconds in a month. So there are 60 seconds in a minute, there's 60 minutes in an hour, 24 hours in a day, and let's assume 30 days in a month. And what we find when we do that calculation is that 50 megabits per second non-stop sustained will generate 16.2 terabytes per month. So we take the first 10 terabytes and multiply that times 8 cents. And we take the remaining 6,200 gigabytes and multiply that times 0.85 cents. And we find out that the data transfer fee from Amazon will be $1,346.
Now, Bill, just a quick question. Is it's 8 cents for the first 10 terabytes, or is it 85 cents, I'm sorry, 0.085 cents for 8.5 cents for the first 10 terabytes, and then it drops after that?
You're correct. I have a mistake in my slide. It's 8.5 cents for the first 10 terabytes and 8 cents for the remaining. I've got a mistake in my slide.
But the overall math is correct, because I was just looking at the paper copy, and the paper copy still, the total comes out right. It's 1346. It's just that we got these numbers swapped. But that's all right. That's all right. Just that's okay.
No, thank you for the correction. I'll fix the slides for the next set of walkthroughs.
Sure.
So what's really striking about this analysis, guys, is that if you look at the cost of accessing the cloud service over the internet transit fee is almost non-material. It's $100 per month as opposed to $13.46, which is what Amazon charges you for the data transfer fee. Having said that, $14.46 is the total cost per month, and it's also interesting that if you divide 1446 by 50 megabits per second, you find that the actual all-in cost on a unit basis that you're paying is about $29 per megabit per second. $29 per meg, of which $2 per meg is your internet transit fee. So to me, that's a rather interesting observation.
It doesn't matter if it's $2 or $4. It's between 2 and 4 somewhere. So yeah. If it's 4, it's a little bit larger fraction, but if it's 2, it's really small.
That's right. And for those who are, doing a lot of traffic but are spending $1 or less per meg, it really disappears into not being a material cost at all.
Sure. Got it.
Okay, so if there are no questions on the Internet Connect service model, that's the cost, and those are the pros and cons. Let's do the exact same analysis on the Direct Connect service model and see how that fares out.
Yeah, let me just remind those who are, there are 4 people viewing, so let me just remind them that if you have any questions, you can use the group chat window, or you can actually go to Bill's post in the Carry Ethernet group, the link to which is there in the abstract, so you can put a question there. So I'm periodically checking to see if there's any questions both in the chat and the post, but in the meantime, we can keep going, Bill.
Okay. So we'll take a look at the Direct Connect service model now. This refers to a system of directly connecting the enterprise to business-critical cloud services. So you see here on the picture, we're not talking about replacing the internet in this model. People will continue to buy their internet transit service. What we're saying is that the Direct Connect service model is a way to get directly connected to mission-critical destinations while sending everything else through the regular internet. So in this way, the Direct Connect service model is actually complementary to the Internet Connect service model. Well, what we're suggesting is that you need to identify those cloud services companies for which there is a mission-critical need to be directly connected. Now, when I say mission critical, what do I mean? I'm using the following definition, and I'm trying to get a sense from the audiences I talk to if this definition makes sense. So my definition of a mission critical cloud service is one where if it was down or unavailable or performing poorly for 1 hour during your busy periods or during a crisis period, that would adversely affect your business. So I'm saying 2 things here. It doesn't need to be I can't access. It could be an internet brownout where the performance is so bad it's all but unusable. Maybe it's a video chat conference like what we're having here, but it's so glitchy as to be unusable. Or maybe it's access to Salesforce.com and your people are having so much wait time that they practically call it unavailable, even though traffic is still being routed to that destination. So for that definition, what are the mission-critical destinations for an enterprise? My estimate from working with these various different companies is that the number of mission-critical destinations tends to be between 5 and 50. That kind of order of magnitude. 10 or 12 seems to be a reasonable number. If you take a look at what your enterprise does, chances are good that you're using Salesforce for your CRM. You're probably using Box or Dropbox for your storage. Perhaps using Zendesk for your help desk facility and so forth. If you go through those destinations where your people are depending on them being available, they would be less productive if they weren't available, and maybe they would not be able to generate the reports they needed for a particular event. Those would lead towards one saying, well, these are mission-critical services for our enterprise.
And that number is, yeah, so that's a pretty small number in the grand scheme of things. I mean, yeah, some very large enterprises may have up to 50, but a dozen or less is probably the sweet spot.
That seems to be what's coming out in the field.
Sure.
The other thing that we find is, one of the things that Console does is it uses an ecosystem mechanism. So if you look at all these individual interconnects, because you're connected into the ecosystem, connecting to additional cloud services is as easy as pointing and clicking a button. So the easier that one can make it to add additional cloud services directly, the more likely one is to get up closer to that 50 number as opposed to the 2 or 3 number.
Got it. So yeah, I mean, if the enterprise is doing it all by themselves, that number is likely to be slow. If you're going through an exchange where that's provided in a point-and-click fashion, and some of those connections are already available, and you're simply, cross-connecting to them, then yes, the tendency would be it'll be a lot easier to start using more of those.
That's right. The other thing that I'll point out is that the way that we do it is when one of the console customers is connected into the platform, when they're pointing and clicking, it doesn't just set up a connection between the enterprise and the cloud company. It actually configures routing configures a virtual router called a cloud router to enable the passing of traffic automatically. So it's not just a matter of providing layer 2 connectivity. We actually have the solution that will automatically configure the routing so that it works for the enterprise.
Cool. And maybe I should bring for a moment Dumisani into the conversation and then find out if, what are the trends they're seeing in their part of the world. I mean, are there, is there a movement to this kind of it? I know earlier on, before we went live, Dumisani, you said that, the interest is coming because some of the enterprises are beginning to think about this. So what's your sense of how it's going in your part of the world?
It's actually, there's a lot of interest around this, but I'm actually looking at the litmus test that Bill here uses. It's actually very interesting, classifying what is important for enterprises. We've actually found email in my market is very important in other segments of the business. So guys who are very much driven from an email side of things consider email as an important part. Using Office 365, for an example, it's hosted in the cloud, and guys want to make sure they have constant access to it. A lot of travel agencies have a lot of service. They're not generating any revenue. And it is important for them to actually put that as a business critical service. And when it's put that way, it makes it very easy. But going back to your comment.
Because if you read Bill's paper, we all tend to think of email as a non-critical service. So it's very fascinating to hear that, the businesses are dependent on email and other such connectivity. And they deem that to be mission critical.
It's exactly that, Vishal. And it's getting your clients to think deeper about what drives their business. And that's where the challenge sometimes is. And sometimes when you ask the question as basic as Bill has put it there, so what applications do you need today? And if they are not available, what's the impact on the business? If they are not productive, what happens? And that answer alone gives you a wealth of insight into your customer's environment. So that's something that we found as well interesting in my space. But speaking to a direct connect environment, we're finding it as becoming popular as well. So we've launched our own product called Cloud Connect, going back to different names. Ours is called Cloud Connect, and maybe we'll touch on the different private connect technologies you can use. So Carrier Ethernet, ours is based on MPLS as an underlying transport mechanism. So it's definitely growing on our side as well. But what's interesting here in the conversation is I'm finding this to be driven a lot by cloud, at least coming from Bill's end, or cloud providers. On our end, it's mostly driven by service providers who own the client relationship. And the client is saying, how can I securely connect to my services that are hosted by Amazon or Microsoft Azure? So we have to now go through the likes of your Equinix and your Amazons to actually find the service. So it's a different take, I must say. But it is here as well in my market.
So it's very fascinating because the need for the service is the same, but the push for the service and the direction from which it's coming is quite different in these different markets.
Exactly, Vishal. And that's the interesting part. You're right. It's very fascinating.
Okay, wonderful, great. Yeah. Well, Bill, we can continue now with this, with the analysis.
Yeah, so one of the questions that I put to folks was, okay, so you've identified certain mission-critical services that your business depends on. Why would you want to go direct? What is the bang for the buck that you go by using a direct connect service model? And the first answer is, again, security, that if you look at the path between the enterprise and the cloud company, you see it's merely this straight line. There's no routers in between point A and point B. This is an internet bypass. This could be a point-to-point circuit. It could be an MPLS virtual path, but it's dedicated and there's no addressable router in between point A and point B. So this is what the security guys would say is a smaller attack surface. And that's one of the key benefits there. The greater reliability has to do with the fact that the traffic exchange between the enterprise and the cloud service is immune to the side effects of whatever craziness is going on across the commodity internet. whatever DDoS attacks are going on, it doesn't matter to the traffic that's directly connected. That traffic will flow just like in the Priceline example, the A/B test that they did. The spikes that they'll see on the transit path simply do not show up on their direct connect path. The third pro, go ahead.
Sorry, man. Just a quick question. I'm looking at the model now. What would you say is the preferred private connection for Amazon today? I know we're using Amazon as a base standard. Would it be point-to-point? Would it be MPLS? I'm just thinking managing multiple point-to-point connections from different enterprises must be a challenge. Do you have a view into how they are currently doing this today?
Yes, we believe that the enterprise will not embrace a complicated solution. What the enterprise needs is a completely automated turnkey solution, because generally speaking, the enterprises don't tend to have a large network engineering team that is comfortable configuring routers and setting up point-to-point circuits, going down the co-location path itself. That's not typically the enterprise perspective. The other thing we see on the flip side is that the SaaS companies themselves are getting more and more of these direct connect requests. What happened with one of our SaaS customers is last year they got 4 requests for a direct connect-like solution so that their customers could directly connect into their cloud service. They got 4 last year. The first quarter of 2015, they got 40. 40. And one could say, well, why do you think that big increase happened? And I keep on pointing to the DDoS attacks that are wreaking havoc across the internet. Those 300, 400 gigabit per second attacks do, in fact, impinge upon the reliability for the traffic flow for the rest of us who are not involved in those DDoS attacks. So the fact that we're seeing those kind of numbers really means that the SaaS company is under some degree of pressure to provide a better service, a better end user experience to their customers. And the other thing I've noticed since I've been working on the peering stuff for 20 years, this really is nothing new to the networking community. We all know that if you want to have better reliability and better performance, you peer with one another. The different thing is that the SaaS companies are not ISPs either. They very often don't have a large network engineering team. They have a few folks that want to do the right thing, but hand-holding all the enterprises through the manual configuration process and debugging activities, that would take more than a couple of full-time engineers to get that set up and monitor and maintain it. So that's really the big problem. What we're doing is simply connect to our ecosystem, and from that point forward, it's merely a matter of pointing and clicking. So that relieves the pressure from the SaaS company, who no longer has to help the enterprise through the manual configuration, and it helps the enterprise who doesn't have the ability sometimes to configure routers and get connected directly. So we like to say that we not only give the grandmother the car and the road, but we automatically get that car driving down the road for her, so she doesn't need to be involved with all the details.
So you've become an extension of the cloud providers then, Bill, to help them deliver this service.
That's a great way of putting it, Masani. Yep.
But Bill, one question. So how do folks like Amazon manage all these direct connect requests? I mean, they don't have an exchange, or do they? Have they set up something where they have like an office or data center that you've shown here, and then they are direct connect things to the Amazon cloud, which is all controlled by Amazon, and then the customers are only connecting to something like this? Or are they handling a multiplicity of direct connections directly coming into the Amazon cloud and their different cloud services?
Yeah, well, Amazon has things split up into different regions, and they have a control panel where you configure the Direct Connect. But in order to use Direct Connect, you need to, that's actually very much in line with this slide here. I have it listed as a con, but it's not really a con. The point is, if you want to use the Direct Connect service model, you do need to do something from the network perspective. Unlike the Internet Connect service model, where you can use your existing Internet service, Here you actually do need to contract with an Amazon-blessed transport provider. Amazon has, I think, something like 80 different Amazon preferred network partners. We are one of them, but you do need to reach out and use one of us to get connected to that Direct Connect port.
Sure, sure.
Okay, in the interest of time, maybe I can scoot forward.
Yeah,
So there are three cost components to the Direct Connect service model. The first is the Direct Connect port, which you lease from Amazon. The second price component is the data transfer fee, which is the metered, the volumetric amount of traffic times the cost of the data transfer fee. The data transfer fee, instead of being 8.5 cents per gigabyte and 8 cents per gigabyte, is actually much lower than that, and that's where a lot of the cost savings for Direct Connect comes in. And then finally, you do need to pay for a network transport provider to get your network connected to that leased Amazon port. So let's plug in some numbers and see how that works. First, let's take a look at the Direct Connect port. On the Amazon website, they'll show you that you can lease a Direct Connect port from them on a per-hour basis, which is a very cloud way of doing things. So you see here the price points for 50 megs, 3 cents per port hour, 100 megs for 6 cents. Now, in our case, we're comparing the internet versus Direct Connect, so I'm going to argue that we ought to hold that port on 24/7, just like the Internet Connect pricing model. And if we do that, we can calculate how much that's going to cost to lease that port. Now, you notice that in the Internet Connect service model, I said we're going to have 50 megabit per second of non-stop sustained bidirectional traffic. 50 megabit per second. Now, the reason that we're doing Direct Connect in the first place is to improve performance and reliability. So I'm going to argue that we probably won't use a 50 meg port to deliver 50 megabit per second of traffic. We're going to instead lease a 100 meg port so we have some headroom. So we're not getting congested, we're not dropping packets because the pipe is too tight for us. So let's go ahead and plug in those numbers. We're going to use a 100 meg port. It costs 6 cents per port hour, times 24 hours a day, 30 days a month. We see the cost for leasing that port from Amazon is $43.20 per month. So that's the first cost. The second cost component is the data transfer fee. As I said, Amazon has different regions around the world, and they have different price points for Direct Connect in each of those regions. In the United States, the prices tend to be 2 or 3 cents per gigabyte. Just because I wanted to make sure no one would say I was cherry picking the lowest possible number, I'm going to use the higher number here of 3 cents per gigabyte. Now, remember here that 3 cents per gigabyte out for Amazon's data transfer fee is about a third of the 8.5 cents or 8 cents per gigabyte. So there's actually some substantial cost savings here. So if we take our 16.2 terabytes and multiply that times 3 cents per gigabyte, what we see is the data transfer fee in this case is $486. Now this is remarkable because the data transfer fee when you connect over the internet for the exact same traffic pattern is $1,346. When you go direct, it's actually $486. But you do need to get to that Direct Connect port. So I asked one of our sales guys here, what would it cost for a 100 meg service delivering 50 megabit per second committed information rate? What would that cost? And he said, well, it depends on the endpoints. I said, well, we're going to the Amazon New York location, the core site facility, where it's in New York. And he said, well, where's the other endpoint? Now, we at IIX had popped a building in Oklahoma City called Rack 59. Very nice facility. It's in the middle of the country, and we figured, well, that might be a good place for us to get a sample circuit cost. And the round number circuit cost I got for estimating in this model was $500 a month. That's $500 a month will get you 50 megabit per second committed information rate on a 100 meg port. Some people said the price might be higher. AT&T, for example, might be more like $1,200 or $1,500. There might be some other guys who might come in lower, but for the purposes of this model, $500 a month seems to be a reasonable price point. Now, the last piece I'll point to is I'm going to argue that the direct connect pricing model should be able to take credit for the reduction in internet transit fees. That is, that 50 megabits per second that used to go over the internet is now being shifted to go over this direct connect pipe that we put in place. So we should be able to reduce our internet transit fees by $100 per month by doing the direct connect approach here. And we ought to be able to take credit for that in the direct connect model. So if you add all these together, you see $43.20 for the direct connect port fee, the $46 for the data transfer fee, $500 per month to get you to that Amazon port, and then you're saving $100 because you're not using as much internet transit. You see the total cost for the direct connect service model is $929.20 per month. And this is actually remarkable because if you compare that against the cost of using the internet, of $14.46 per month, you're actually getting not only better performance, better reliability, better security, better control and visibility, but it actually costs you less in addition. To me, I found that to be really striking, and that's one of the main reasons I wanted to write this paper and get it out. This is actually quite an interesting analysis. I'll pause there for a minute and see if you have any reaction.
Yeah, so let me just remind people that are viewing, if you have any questions, please use the group chat or just put them in into the LinkedIn post that Bill had. Of course, you'll have opportunity to ask questions later because this is information that people are still processing. But one thing that, Dumisani, do you have any thoughts or observations or questions at this point?
I'm actually looking at the results or the findings of that Bill has just shared with us now, and I'm thinking, you really need to understand your traffic patterns very well between the two models. If we use the consistent 30 days approach and we assume it's a constant stream, it definitely makes more sense to go direct connect. But I'm thinking if I'm sitting and the service is accessed infrequently by my users, I can still go the internet transit route, in a sense that it's only $2 that I outlay initially for the internet service. And if it's not a lot of data that's access or comes out of the cloud services, then the model will probably still make sense. So
no, but then come into the question of what services do you want to go over the internet, and that's I think one of the thoughts was that we're treating this complementary to basic internet-based access, right? So for critical services, yeah, from a cost perspective, we can go with the internet. But then what about performance? Like you said, some things are so critical that you don't want them to be impacted by poor performance in the general internet.
No. For now, I'm looking at completely around cost alone, and I'm assuming, yes, on cost alone. But more to it, where I'm driving to is, again, enterprises need to really be educated about what they're trying to achieve. And this is why direct connect, again, makes more sense, because the usual argument is, but the internet is cheaper, so going over the internet. But when it's presented this way, for a client who understands exactly how frequently the service is used by his business and its importance, he can make an educated decision to go direct, and knowing that it's better performance and security, but also the cost benefit. Before, we couldn't position the cost benefit. It is usually in contrary to everything else. You could position performance, reliability, and security. But when it comes to cost, it's been always, oh no, the internet is cheaper.
Yeah, that's a good point.
Exactly. This is contrary to these findings.
But there's one thing, Bill, I did want to point out. I mean, there seems to me that the network transport cost is kind of a big variable here, right? Depending on your provider and how much you can arm wrestle them based on how competitive your market is. I mean, it can vary up by a factor of 2. So it's possible in some markets, the direct connect might become cost comparable or a little bit even more, in quotes, expensive compared to the number that we came up with for internet. Because if the cost is, let's say, $1,000 as opposed to $500 for network transport, suddenly the direct connect cost becomes about $1,400, and now you're almost the same in cost. And if it's $1,200, God forbid you use AT&T or whoever, then they're a little bit more expensive. So it seems that's a huge variable in there that people have to pay attention to.
Yes, and thank you for bringing that up. That's a fairly common point that comes up during the walkthroughs. Here we are. I'll restate your point in another way. Here we are looking at infrastructure as a service companies like Amazon Web Services and Google Cloud and Microsoft Azure, who all have a data transfer fee, and they are incenting people to connect directly by adjusting their data transfer fee substantially down so that you'll save money, so this would work. But how about those companies like SaaS companies that don't have a data transfer fee? What are the motivations there? And what I find is that the SaaS companies are very much like the content providers in the peering world. They really care dearly about the end user experience. To them, they are willing to pay more because they want the complaint phone to stop ringing. On the enterprise side, they don't necessarily know that the problem is an intermediary ISP that's having a bad day with DDoS attacks. What they know is that the users can't save to their box file store. And they point their finger to IT, and the IT people point their finger to Box as a service provider who's not giving them access that they need. So you have two sides here that both care dearly about the interconnection between them. These guys are not going to do it because of the cost reasons. They're going to interconnect because they want that better security, better reliability, and better performance, better control. And they are willing to pay more money to achieve those ends. It just so happens that this business case that I stumbled upon works out really quite well for the sector of the market that is doing direct connect to Amazon Web Services. But you're exactly right. What happens if there is no data transfer fee? And that's this next slide here. Working with the SaaS companies that do not have a data transfer fee in the enterprises, what they tell me is that the value of that traffic that they exchange with the cloud company is worth a whole lot more than the $1 or $2 per megabit per second suggests. $1 or $2 per megabit per second is very inexpensive, but the value of the transaction is substantially higher than that. And that's easy to say. The question I then went down the path to answer was, well, how much is this traffic worth to the enterprise? And the answer seems to be, well, what is the cost of not being able to access that service? And you kind of imagine your salespeople sitting around twiddling their thumbs, not able to update their records in their CRM, or a team that's aggressively trying to hit a deadline and they can't because they can't save their files to a particular storage system or what have you. Or in some cases, I listed 3 of the things that come up: lost revenue. One of the social networking platforms that's our customer said that when they put ads up on their user interface, the way it works is they have a bidding process with the ad network, and a request will go out and they have to respond within a certain period of time, otherwise they don't win the right to display that ad. So to them, network performance really gets linked to the ability to get the revenue for displaying the ad and the click-through revenue. And if they don't have good network performance, they will not get that revenue. Here's a direct tie between revenue that will be lost if they don't have good connectivity to that particular service over the internet.
Sure.
And then one can take a look at the damage to the brand. If you're having a bad experience staving to your SaaS storage service, and you, for whatever reason, your team cannot make that work for you, then you're going to start looking at the other SaaS companies that offer a storage service. So the damage to your brand is the damage to the experience, and these customers that are leaving you, you have to take a look at what does it cost to acquire and keep a customer. Can you keep that customer happy? And having a direct connect solution provides a way of getting them better performance, a solution to the problem that they had. And then the cost to repair. How many hours are your staff going to be spending in meetings talking about what happened, doing the post-mortem analysis, and identifying what's the solution towards the future? If you add up all those costs of not being able to access a critical SaaS or a critical cloud service, you have to compare that cost against the cost of Direct Connect. Maybe Direct Connect is going to cost you $200 a month more, or $500 a month more. Is the cost of the downtime going to be greater than that? That's the litmus test, and that's the analysis that you would do.
Exactly. Exactly. That's very cool. Is there anything else that we want to talk about as we look at this?
Yeah, if I could just get back to the final slide here, and then we'll let Dumasani go. I think what I've stumbled upon here is a fundamental clash between the best effort internet and the increasing need for access, high availability access to mission critical business applications. I think ultimately the solution is going to be that you want to merge the two. The right solution for any enterprise is going to be some combination of internet transit combined with direct connect access to the mission critical destinations. And if you do that, I think you're going to have the best solution available. In fact, I would go even further. I would say that depending on the best effort internet for mission critical business applications is more than just risky, it's downright negligent, because there is in fact a high quality alternative by merging these two solutions together.
Absolutely, but we have to remember that this is this is a fairly recent vintage, right? I mean, before that, enterprises didn't have that choice, and in many markets today, that may still well be the case. I mean, it's evolving, and the enterprises are asking for it, and the operators are responding, as Dumasani was saying. But it's something that in more evolving markets, it's something that the enterprise may not have a choice till the operator makes that, or the cloud providers start making that available. They're local cloud providers.
Yeah, I think one of the things that we're doing to try and help spur this initiative along is that we've created a network service provider partnership program, so that any network service provider out there that can get a circuit into our ecosystem can then turn around and offer to their customers a direct connect service. And they can use the same point-and-click interface I've been describing on this call for their customers to directly connect to their mission-critical destinations. So in that way, we're alleviating some of that pressure on the enterprise side and on the SaaS side to provide better connectivity by using the NSP partners and their customer base and passing on this service into their ecosystem.
Absolutely.
So, well, listen, that's a great idea, but it seems to be in line with what Equinix is doing, where service provider would connect to them and they would connect to the SaaS provider. Is that the same model?
It's similar but a bit different. The Equinix Cloud Exchange model is a great service for providing access to those who are within the Equinix data center to connect to a SaaS company that's also within that Equinix data center. But if there's a service that is not within that same Equinix data center, then you would use someone like us.
Oh, okay. Again, providing greater reach.
Yes, we connect to the Equinixes, the core sites, the telecities, the telehouses across Europe and such. So yeah, we've connected in all these locations, and really the sweet spot for us is connecting to cloud services that may be any location anywhere around the world.
Bill, one more point. I just want to verify this. But maybe the Equinix service doesn't include the configuration of the routers and so forth that you were talking about. Maybe it does. I'm not perfectly clued into that. So maybe that's another sort of difference in the way the two services are structured.
Yeah, so that's right, Vishal. Thank you for reminding me. That's really the key differentiator for console. I didn't really want this to be a console sales pitch.
Yeah, I understand that.
Yeah, of course.
We're talking about it.
Yeah, but the reality is, it's interesting. When I've done these walkthroughs, these last couple of SaaS companies have actually given me some grief for not pointing out some of these benefits that we're putting forward in the market, specifically the automated configuration of Layer 3, so that the enterprise and the SaaS company don't need to worry about configuring routers. But more importantly, the fact that one cross-connect into the cloud service that we offer, the ecosystem, one cross-connect can give you access to virtually an unlimited number of SaaS companies directly. That's one thing that differentiates our service from, say, a point-to-point circuit provider, where you can order a point-to-point circuit to one company, then order another one to another one, another circuit to another one. Each one's going to have a certain amount of time and delay, and it has to be managed independently. We take care of all that, so it's merely a cross-connect and a point-and-click. And the SaaS companies were giving me grief for not bringing it up, because to them that's a substantial benefit to their enterprise customers, and they want the enterprise customers on the ecosystem.
Absolutely, absolutely.
Well, guys, thank you very much for your time. And one last thing, a lot of folks have contributed data into this white paper so far. If you have comments or suggestions, please send them my way. I'd love to add you onto this list. And hopefully we'll have a good community paper that we can all use to help folks get directly connected.
Absolutely, absolutely. No, and I also, actually, if you stop your screen share, then we can do the last 30 seconds video interaction. Great. Oops. Yeah. So great. So yeah, thank you so much, Bill, for doing this. This is wonderful. Thank you to Misani for joining us, and the other viewers. I always like to thank everyone for the time that they've put into it. And I think this will lead to a good conversation, probably on the group, or as people think more about the paper. So when are you actually going to physically release a draft version that people can actually read? Because I think a lot of people thought that they will get to read the paper. So that may happen at some point in time.
Yeah, the current thinking is I still am getting good feedback. And when I say good feedback, I don't mean good job, Bill. I mean,
no,
good feedback to me is you need to include this particular thing, or here's some ways where your logic falls apart, or that type of stuff. So I want to put something out, but once I put it out publicly, it kind of gets locked and frozen in place.
Got it.
In particular, what's interesting is what came up on this call is a consistent thing. The paper does a good job for that segment of the market that has a data transfer fee, but all of the focus on the cost is unimportant when there is no data transfer fee. Then you need to turn the focus on what is the value of that transaction to you as an enterprise. And if you value that traffic as, let's say, $400 or $800 an hour, then the direct connect fee shouldn't cost more than $400 or $800 an hour. That's the type of analysis that people seem to want to have in this paper that I don't have in there yet. So
I
think
that's a very good point. That's a very good point, because, and that brings us back, it circles back to what Dumisani said, which is educating the enterprise on beginning to recognize, what applications are really critical, and then even beyond that, based on what you said, Bill, which is putting a value on it. I mean, they have not, they kind of have done it intuitively, but now they really got to put numbers to it and then compare that to, how critical that is in value terms. And it may be even maybe more than a few $100s, per hour. If your entire sales force is down, or as you said, if the ad network is down, we are talking huge amounts of transactions and huge amounts of dollars, in that 1 hour.
That's exactly right, and that could in fact dwarf all the numbers that we're talking about here.
Exactly.
I mean, I was all excited that I found that wow, not only do you get all these benefits, but it's also $500 per month cheaper. Well, $500 a month cheaper is peanuts compared to the cost of a room full of help desk people who can't access their help desk software.
Yeah, or as Dumisani said, the agents cannot access their email and cannot make reservations and so on in South Africa.
Exactly. Yeah. It almost throws a challenge back to cloud providers to say, provide more education to the customers before they take the service, or to these enterprise clients. They were not geared up for this yet, but they now have to provide the education. And I would imagine you, Bill, and your organization provide that role for them. You sell through a SaaS provider and educate the end user on what to think about before taking up an Amazon service, for an example. Because usually what happens is you have clients who've already taken it up. They like it, but they don't think about everything that it encompasses. And some of the things are around how you're going to connect.
Exactly.
Yeah, so I think to answer your question, I'm expecting we should be able to have this white paper out in a matter of weeks, if not a couple of months. But really, the challenge to me is how can I convey the value of that traffic in a way that will make sense to the enterprise reading it. And specifically, one example that came up is, well, what is the cost if a travel site can't take reservations for airplane tickets? Well, those are $400 purchases that are not going through at this point.
True. Exactly.
So there's all kinds of different math that one could do, and I find as I'm starting to talk through these things, I'm waving my hands a whole lot more without having any data, you know. So I need to have some way of modeling that, or coming up with a table that says here are some sample numbers, and in the worst case scenario, it doesn't matter, you know, that you're saving $500, you know, per month because you're using Direct Connect. What really matters is that you're not having $3,000 in lost customers and brand damage and lost revenue and such. So getting some story around that is a challenge.
But I think what one way to do it might be to keep the core of the paper on cost, just as a way of illustrating and getting people to think about it. As Dumisani said, you know, prior to this, even the operators had no way to actually quantify stuff. So now at least there is a benchmark. Even if it is, you know, even if it is just qualitative in the end, it may turn out to be a qualitative exercise. But then you could have appendices for different classes of customers, like you said, the SaaS operators that don't have a Direct Connect fee, or other kinds of enterprises, or this, you know, this whole where in an appendix format, you know, these different considerations are reflected, but without affecting the core paper itself. Because otherwise, you'll need to keep rewriting it over and over again, or you'll need different versions for these different classes.
Data will keep on changing. You're gonna get different information, and it's always hard to quantify some of those lost revenue items. I think right now you've chosen the right pillars: lost revenue, brand reputation. That's everything most customers are worried about, really. And if you focus on it in that sense, it might be easier for the guys in the enterprise world to pick it up, because that's the world they live in.
Right, but I think that you need one version for the operators just to get their head around it, and another version for the enterprises to appreciate the value.
Split it up.
That was actually one of the thoughts I had, was maybe the right answer is going to ultimately be that we have a separate paper that's for SaaS companies that don't have a data transfer fee, and that would be entirely focused on the other benefits of Direct Connect. So I don't know. I think what I have right now is a very solid piece. Amazon loves the thing. Most of the SaaS companies I've talked through this love this thing. They think this is a good way to help them get the message to market. And a white paper seems to be the right format for educating the audience. So.
Yeah, absolutely. Well, that's great. That's great. So, any other parting thoughts, guys, before we sign off?
Oh, thank you very much for your time and your feedback, guys. I really appreciate it, and that's going to help me work on the second white paper.
Yeah. So, thanks again, everyone. And as I always say at the end of every CE Live, you know, may the bits in your bytes and the bytes in your packets remain profitable. And we'll see you next time.
Thank you, gentlemen. Vishal, Bill. Bye.
All right. Have a good one.
Cheers.
Bye-bye.